9.1 is mathematical patterns, and we're going to be talking about sequences and series, but we need to get our feet wet first. First set of problems says find A6. When they say A6, all they mean is the sixth number in the pattern. 1, 2, 3, 4, 5, sixth. A6 is going to be the next number in this pattern, so we need to see what's happening there. And you look and you want to try to see how to get from one number to the next. And in this case, it looks like they're adding 10. And you want to double check and make sure that it's doing the same thing. Add 10, add 10, add 10, add 10. Yeah, sure. So as long as we add 10, we should be able to get the next number. A6 is equal to 24. So then the next one, we still want to find A6. So first, second, third, fourth, fifth, sixth term. And we have to try to figure out how we're getting from one number to the next. Well, right here I see plus 5, but right here I see plus 7. Okay, go backwards. That must have been plus 3. I see the pattern. This one would be plus 9. So to get to the next term, it looks like we'd have to add 11. You're just looking for the pattern. 23 plus 11 is 34. So maybe we should write it like this. A6 equals 34, or A6 equals 24 on the last one. Next set of problems is a little bit harder because we have to find the 10th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want to find the 10th number. So again, we have to try to figure out what's going on. So what are we doing? We are subtracting 3, subtracting 6, subtracting 12, subtracting 24. There might be an easier way of doing this. Oh, I see a different way of doing it. What if we multiplied by 2? Times 2, times 2. Yeah, that looks a little easier. So we multiply by 2. Maybe you want a calculator for this one. Negative 48 times 2. It's negative 96. Times 2 is negative 192. Times 2 times 2 times 2, negative 1536. That's your answer right there. The 10th term, that's what this means. The 10th term in this sequence is negative 1536. Same question, number 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the 10th term. So we need to figure out what's happening. It looks like maybe times 4, times negative 4, times negative 4, times negative 4. Usually once you see it happen a couple of times, yeah, it looks like we're multiplying times negative 4. So let's start with 256 times negative 4. That's the 6th term, times negative 4 is the 7th term, times negative 4, that's the 8th term, times negative 4 is the 9th term, times negative 4 is the 10th term, negative 262, 144. I didn't really care what those other terms were. All I care in this problem is what's the 10th term. Find the first 4 terms in each recursive sequence. All right, so we've got an important word here, recursive. When they talk about recursive, they're going to use previous terms. And this seems confusing, but we do this all the time, all right? So in order to do a recursive, you have to know where we start. And they're telling us where to start. They're telling us the first term is 25. So what we want to do is figure out the second term. And so the second term, we're going to look at this formula. And this formula looks really confusing because you see a in and a in minus 1. But a in is just basically whatever term you're looking at. And a in minus 1 is the term right before that. So all that means is it's the previous term. So in order to find a2, what we're going to do is we're going to take the previous term. The previous term was 25, so we're going to take 25 plus 100, and that's 125. Okay. Now we need the third term. Take the previous term, which was 125, and add 100. That's what the formula says. That's 225. Now a4. Take the previous term, which was 225, and add 100, and you get 325. So the direction said find the first 4 terms in each sequence. Well, the first term was 25, and then 125, 225, and 325. Number 11, same thing. They give you this formula, but they also have to tell you where to start. They have to tell you this. If they don't tell you where to start, then we don't know what to do. But it's a recursive sequence, and you can tell it's recursive because they're using a previous term here. We want to find the second term. We already know the first term is 3. So what this says is we're going to take the previous term and multiply by -6. So we've got -3 times -6, and that's 18. So now the third term. You take the previous term, which was 18, times -6. -108. Now a4. You take the previous term, which was -108, times -6. That's what the formula says. $648. So then our first term was -3, second term 18, third term -108, and fourth term 648. Find the first 4 terms of the explicit sequence. So this is different. Explicit is different than recursive. Explicit means we're going to plug in the in value. And the in value is going to be different depending on what term we're looking at. But this time the explicit sequence, it doesn't give us a previous term, it gives us an in. And that's where we're going to plug it in. So we want the first 4 terms. So let's think about the first term. A1 is what you would get when you plug in 1. Notice this is in, this is in. We're going to plug that number in. 1 squared plus 2. That's 1 plus 2, that's 3. Now the second term. We are not doing recursive, so we do not plug in the last term, we plug in the in number. And the in number is this number right here, 2. So 2 squared plus 2, that's 4 plus 2, that's 6. A3, we're going to plug in 3. 3 squared plus 2, that's 9 plus 2 is 11. And then let's do the fourth term, plug in 4 squared plus 2, that's 16 plus 2 is 18. First 4 terms, 3, 6, 11, 18. Let's do another one, explicit. Now again, remember the difference between explicit and recursive. Recursive, you use the previous term. Explicit, you're going to use in. So for number 15, we want to start and find the first term. That just means we plug in 1. Sometimes you can do stuff in your head, and sometimes you better clean it up. But 1 minus 1 is 0. 3 to the 0 is 1. 2 times 1 is 2. For the second term, you plug in 2. So notice where n is. That's where you plug in this number. 2 times 3 to the second power minus 1. Order of operations says do exponents first. That's going to be 2 times 3 to the first. That's 2 times 3. That's 6. Third term, plug in 3. 2 times 3 to the 3 minus 1. That's 2 times 3 squared. 9 times 2, that's 18. Fourth term, plug in 4. 2 times 3 to the 4 minus 1. That's 2 times 3 to the third. 3 to the third is 27. 27 times 2 is 54. So first 4 terms, 2, 6, 18, 54. Write the recursive formula for each sequence. You got to remember, recursive formula meant we're using previous terms. So the one right before an was an minus 1. That's what we're talking about when we're talking about previous terms. All right, so this is a little bit hard to get started. For recursive, we do definitely have to know what A1 is. And we can see A1 is 4. So that's a big deal. That's where we start. And then let's try to get a feel for what this pattern is doing. So plus 4, plus 8, plus 16. How about times 2? It looks like times 2, times 2, times 2. Yeah, that's it. Okay. So what this pattern is saying is in order to get to the term we want, we take the previous term times 2. Don't forget, we have to also say where we started. We started with A1 equal 4. This is your answer. Your answer has 2 parts. Recursive formula is going to have your formula, but it's also going to have the first term. So we look at the next one. Recursive formula, we need to know where we start. That's A1. But we also want to feel for the pattern. What are we doing here? Plus 20? Plus 20, plus 20, plus 20. Okay. So the formula is going to be an equals previous term plus 20. Oh yeah, don't forget where we started. That's recursive. Now we want to find the explicit formula. Remember, explicit formula is going to use n, not previous terms. So you might have an n or an n squared or something like that. So let's see, what are we going to do? Okay, so we can see we start at 6. A1 is 6, and you kind of do the same thing. We look at the pattern, plus 10, plus 10, plus 10. Looks like we're adding 10. All right, but we don't want to do the same thing as what we did just a second ago. We want to find the explicit formula. So I think the secret to this is going backwards. All right, if you knew what was here, that would be a big deal. Okay, so just kind of carry that pattern backwards. What number would be right there? And then if we add 10, we'd get to the first term of 6. Okay, negative 4. This number must be negative 4. All right, so here's what's going to happen. All right, we're adding 10 a whole bunch of times. So if you add it multiple times, there's your n right there. It's going to be plus 10n. So the nth term for the explicit formula is going to be that starting number, negative 4, plus 10n. And you can check it if you want to by plugging in 1. If you plugged in 1, you should get the first term. First term equals negative 4 plus 10 times 1. That's -4 plus 10, and that's 6, and that's what we started with. Okay, so I don't want this. This was just my check work. This is the answer. All right. So that was kind of hard. Let's do another one. I bet it'll be easier. We're adding 4, and it's pretty quick to see that you're add 4 plus 4 plus 4 plus 4. So you do that over and over and over again. That must mean there's a plus 4 in. You can add 4 some number of times, but I think the secret here is if you know this number, you can get to the next number. All right, you can get to the first number. And if I add 4, add 4, add 4, this number must be 24. So 24 plus 4n. AN equals 24 plus 4n. There you go.